Hello and welcome to today's ACM Tech Talk. This webcast is part of ACM's commitment to lifelong learning and professional development, serving a global membership of computing professionals and students. My name is Michael Zeller. Currently, I lead AI strategy and innovation at Software AG. Previously, I was the CEO and co-founder of Mentis, a leading provider of software solutions for predictive analytics. I'm also an ACM member, and I serve as the Secretary and Treasurer on the Executive Committee of ACM's Special Interest Group, SIG-KDD, the premier international organization for data science. For more on my background, please check out the bio widget on your screen. For those who may not be that familiar with ACM or what it has to offer, here is a little bit more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see some of the highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. ACM provides timely computing information published by ACM, including communications of the ACM and Q magazines. And one of my favorites, access to the ACM Digital Library, the world's most comprehensive database of computing literature. International conferences that draw leading experts on this broad spectrum of computing topics. Support for education and research, including curriculum development, teacher training, the ACM Turing and ACM Prize in Computing Awards, and the newly updated ACM Code of Ethics, a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in professional practice. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Before we get started, I'd like to mention a few housekeeping items shown on the first slide in front of you. First, the slides will advance automatically throughout the event. On the bottom panel, you will find a number of additional widgets and resources. If you are experiencing problems with the slides or audio, press the F5 key in Windows, Command R if you're on a Mac, or refresh your browser on a mobile device. Of course, you can also just close and relaunch the presentation. To control volume, adjust the master volume on your computers. If you have questions during this talk, please type them into the Q&A box at any time and click the Submit button. I will organize the question as Sarah speaks, and she'll reserve time at the end of the presentation to address them. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. And of course, check learning.acm.org for updates on this and other computing upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute to fill out the survey and help us improve our tech talks. You may also open the link to the survey at any time from the resources window on your screen. You can use Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag ACMLearning. We'll be watching for your tweets. We also have a new community discourse page to continue the discussion after this webcast, including questions we won't be able to get through the Q&A session. Now, I'm very excited to bring you today's presentation. AI and machine learning are certainly the hottest topics on the planet, and today's presentation is titled Agile Data Science, Achieving Salesforce-Scale Machine Learning in Production by Sarah Aerni. Please allow me to introduce Sarah first. Sarah is the Director of Data Science at Salesforce Einstein, where she leads team building AI-powered applications using autoML. Previously, she led teams in healthcare and life sciences at Pivotal, building models for customers, and co-founded a company offering expert services in informatics both to academia and industry. Sarah holds a PhD in biomedical informatics from Stanford University, where she performed research at the interface of biomedicine and machine learning. So the stage is all yours, Sarah. Without further ado, please take it away.
Thank you so much. I'm so excited to be chatting with everyone today about a topic that I'm extremely passionate about, which is agility in data science. So in today's talk, what I'll be doing is going through a bit of how at Salesforce we have come to the journey of having agile data science, but also really touching on my own journey here as I moved from research into industry and now toward really putting machine learning into production. As always, in Salesforce talks, you'll be seeing their forward-looking statements. If you are making any purchasing decisions on Salesforce products, please use publicly available information in case there are any forward-looking topics covered in this talk. Usually what I like to do is start off by level setting on what it is that I'm referring to throughout this talk when I mean AI and machine learning in production. So historically for me, when I've been on this journey, I certainly started from a researcher in a lab, then moved toward being a data science consultant in a variety of locales, and then lastly now leading a team that actually pushes many, many models into production. And really throughout that time I've experienced many different types of ways to put machine learning into action. So the first that I have on this slide is the example where a model is actually informing a strategic decision. For me, initially, those types of examples were building models using clinical data and maybe some molecular data in order to predict whether or not a drug might be good for targeting a particular disease. In that case, the model itself is actually being used to inform whether or not there should be, for example, follow-on lab experiments or possibly clinical trials. Similarly, in the investment space, there may be risk models to allow ad hoc questions, maybe informing strategic decisions for investments. Another type of model is certainly one that is directly a product, meaning that the very end consumer is interacting directly with it. The example that I often give here is a chatbot or maybe algorithmic trading. It's completely autonomous and works on its own. The last one, which is the type that I'm really talking about today, that my team largely focuses on, is the concept of a model that augments a product. So examples that I've worked on here at Salesforce with my team, for example, are the case classification in the service realm. So this is an instance where customers can use their historic data in Service Cloud, which may be, for example, emails that are sent to their help desk. And those can be used to predict, for example, the topic of what a particular customer has emailed about, and then allows a service agent to take a follow-on action, maybe agreeing that the particular label is correct and sending it down a particular queue for expert response. Another such example is predictive lead scoring in the sales instance, where historical data around whether or not a particular lead, which is for example, someone who has signed up for a webinar who could be then a target for a sale, will in fact convert into an opportunity. This will allow a sales rep to sort those leads and then go in order by the most likely to convert. So really this is the particular type of model that I'll be talking about today. And we'll sort of set the stage for what it is that we're discussing in terms of bringing agility into that space. Now, likely is not news to anyone here, but there are a lot of publications out there talking about the fact that adoption of AI is really required at this point for most industries for the companies to stay competitive. And so this particular publication from Deloitte really points to how many organizations actually view this as a position where they must even catch up at this point in order to stay competitive. And so given that it's so critical to business and really considered table stakes in many instances, why is it that for the majority of businesses, data science and machine learning are still out of reach? Well, there's sort of a few reasons. And throughout my experience in industry, I've seen a wave of addressing those individual issues. So first and foremost is always the access to data. There's been a lot of conversation around bringing in these various silos. So those could be data sets that come, for example, from a line of business or maybe from that customer relationship management platform, and bringing those together into a data warehouse and really trying to solve for data access, meaning integrating those data sets in order to build models. So that's often the first point that needs to be addressed. The next problem that comes along, of course, is just needing access to data scientists. There is scarcity of them out there. In addition to that, we have an ever-growing demand. And so needing to hire and actually have folks that are experienced with deploying is extremely important, and another way that many businesses become blocked. Last and not least, which is really where we'll head in this particular talk, is the concept of deploying these to production. What does it actually mean to move beyond giving your data scientists access and getting those models actually out there in the world and interacting? And this often becomes that last blocker. Now again, looking at the publications out there, there are certainly several conversations around just the need for getting the employment out there, and the fact that today we really think of data scientists as needing to be available, needing to be experienced, and actually often kind of this baseline assumption that of course they need to have a master's or a PhD. And so aside from the fact that there just are not many currently experienced practitioners out there, certainly that need to grow the number of folks with a particular education, whether or not that's actually required, is certainly up for debate. However, it's very clear that we need to make sure that businesses out there are actually able to be successful without necessarily having access to data scientists or the expertise beyond that required. So while the talk today really is not about Salesforce in particular, I will sort of discuss it in the context of how we have arrived at a place where I believe we may have something to offer around discussing the concept of agility. So for Salesforce, what we have done in order to reach the scale of service is actually provide different ways for our customers to access AI without having that in-house expertise. And so while I won't be talking about all of the products that are out there, what I will mention is that we have a platform with many different levels of end users that can be everything from kind of out-of-the-box AI to developer-targeted services. And so you should feel free to check those out as they power that Einstein platform. However, rather than focusing on the particular products, what I will be focusing on is kind of that underlying concept of how it is that Salesforce approaches that democratization of AI, meaning how we enable those customers and why that's important for us. Beyond that, I'll move toward the actual platform that we have built that ships AI to production, and with it really talk about the motivation there. As a data scientist by actual training and then follow on someone who has transitioned into production, I feel I've had the opportunity to try to bridge that gap between software development and AI, and so here I'll really share my own journey. After that, I'll discuss kind of those critical AI components or for the platform, and then lastly talk about metrics, which is really my passion area around what is often missed at the upfront of building any sort of platform for deploying apps to production. So let's take a quick step back. For most of you, this may be familiar, but I do like to level set around how it is that most companies view building machine learning apps. So certainly at the outset of any sort of early stage, there is a discussion around the particular business problem. And at the center of it, of course, is that data element. So data scientists will often sit together with business experts, and they will go back and forth between data exploration and speaking to the business to both help them learn about their data and also for the data scientists to learn how to transform that data and to work with it. It actually often leads to a ton of business insight even at this stage, but of course the goal for any data scientist is to actually build a model. So the inevitable next step is to move toward data preparation, which actually means engineering features, cleaning up that data, identifying any sort of ETL, and then moving toward that modeling stage. So given that we've identified that clean data set, we might be engineering some features. We often move toward building models, iterating, and then evaluating how well that's doing. Sometimes that actually leads us back to the drawing board. Often we can actually, after some iteration, move toward deployment. This is fantastic. Realistically, though, no company is building just one app. And that is really the motivation behind why this discussion around agile data science and the need for platform is super important. Because inevitably what happens is when we're ready to build that second app, we often need to have a second data scientist. We want to add a third one. That means we need a third data scientist. So in general, every company will hopefully have dozens of different machine learning models. Certainly for Salesforce, our scale is quite large. So we have over 150,000 customers, all of whom may be building those dozens of apps. And of course, what that means is we needed to figure out how to make sure that our data scientists and our platforms and our approaches scale. Now, along the way, what we've really learned are several lessons just on the machine learning side. And so what I really want to do right now is kind of pause and share a little bit of what it is that we've experienced in hopes that if you start on the journey yourselves of building a platform, you might think of these in advance. Now, whenever we're working with our customers and the different problems that they're trying to set up, there are, of course, varying degrees of skill set. So how much knowledge or understanding they may have of machine learning certainly varies. And therefore, how much you might need to work with them in order to make sure that their data is prepared, in order to make sure that you build guardrails for them for the mistakes that they may have made. This may also actually be true for the folks that are building out the platform. And so as much as possible to collaborate and to interact is extremely important. Something that might seem kind of obvious to everyone, but certainly for us is a learning around what it is that needs to exist inside of the platform, is that different customers have different data sizes. For you, a customer might actually be a different business unit within your business. It may just refer to a different collection of data sets for building a model. Now, the issue is that if you're building a platform, you will have to use those different data sets and make sure that whatever you are building will work regardless of that data set size. So at the outset, making sure that you're really having the consideration about not only how do you deal with the extremely large-scale data, but maybe very small and quick-to-transact data. Really important for how it is that you consider deploying things into production going forward. Now, classification is not always classification. Certainly for us at Salesforce, where we really allow our customers to build their own models with just a few clicks, this means that while they might be answering a yes-no question, it might be a nice balanced data set, but it may also really be a needle in a haystack problem. Now, while I'll talk a little bit later about the automated machine learning techniques that we use so that we don't need a data scientist to go in and understand whether or not it's a classification balanced problem or a rare event problem, this is certainly something that will influence which algorithms you want to use or, for example, the hyperparameter sets that you're considering. Of course, it very, very strongly influences the concept around evaluation. Since a rare event, if you always just predict that it will not happen, it will appear to be very well performing if you use certain accuracy measures. So little things to take note of. English is not the only language. So at Salesforce, of course, we have customers that use a variety of languages. This is extremely important for many people that are embarking upon using text data. It is not only that it could be another language, it could also be completely different types of characters. It could be using things like emojis. So something to consider when you are looking at your different types of tools, how it is that you will handle different data sets that come maybe in a mix of different languages, or certainly if they're just completely separate, how it is that you handle them. Now, customers love to customize. This is something very specific to Salesforce in the sense that we absorb data from our customers out of their CRM, which are heavily customized. What makes their business successful is how they're able to use our platform to best serve their customers. And so what this manifests for in any particular individual business, if you as a data scientist are working on your data, is that you may not know what the structure of the data is or how your actual business unit has worked with data. And so as a result, what you will need to do is actually interact a lot with your end user and make sure that you understand what is in the data. Just because it's a text field does not necessarily mean that it contains text data. It could in fact be an ID or even a number that is sort of disguised as text. So something to think about. So just a couple more of these. This one is very deeply important to me personally. It's that I believe AI needs to be trusted. The reason why this is so critical is our business users frequently are not experts in AI, and what we need to do is be stewards of the concept of how to use AI both ethically, but also how it is to make sure that our end users feel that the model is actually going to perform well. When you as a data scientist are building a model and you are putting it into production, you are inevitably impacting a business. Those business users are actually making decisions about how to run their business based on your models. And so with that comes a lot of responsibility to make sure that they can understand what's happening, they can interpret those outcomes, and they can trust that changing their business practice using your model will actually lead to an improvement, or that they can understand how to make changes. So certainly focusing heavily on not only saying, I promise it's good, but also communicating and making sure that they have their questions answered is extremely important. Last but not least is the concept of fixing your leaks. This is a concept known as hindsight bias, and something to look out for, both in terms of interacting with business experts, but also anybody who's new to building models. One of the canonical examples that a member of my team gives is the concept of trying to help someone make a decision on which airline ticket to purchase so that they will arrive on time to their end location. Now you can imagine there's a lot of historical data out there about flights that might help somebody have actual models available to them at the time of purchase to say, well, this is likely to arrive on time. So you might have all of the historical flights that include the origin destination airports, maybe the size of the aircraft, the weather patterns, all of the data that you can imagine that is historically available. And if you build models to try and predict whether or not you will land on time, one field that might actually be available to you is the actual departure time, meaning what time that flight actually left the ground. And so while that might mean that you can create an extremely accurate model using that historical data, any future flights will not have an actual departure time. And that is what we consider a leaker or hindsight bias. That is information that has been leaked that is in essence the answer. So if you ever are building a model and something looks too good to be true, make sure that you actually check that it is in fact not a leaker or something that you should not be considering in your model. So given that these are all the things that we've encountered, we have been working very hard to make sure that sort of this traditional process of getting AI to everyone will not require this classic approach. So classically, we really go through the process as data scientists of looking at data, engineering and selecting some features, building a model, maybe calibrating what we want that data to look like when it is passed back, and of course integrating it into the actual application so it could be used. What we have actually done at Salesforce is automate this process using automated machine learning. This allows us to prep any data that's brought in, build many different models, and then actually make sure that that prediction is delivered in context. So I'll go through what that actually means, but as you can imagine, at the scale that we're working at, this was extremely important for us so that we would make sure that we can democratize AI and make sure that it reaches absolutely everyone on the platform that needs to use it. And so really we use the motto of trying to make things as simple as possible in order to achieve the scale that is required. Now, while I've talked through the Salesforce approach to democratizing AI, I kind of want to take a step back and talk about, as a data scientist, the journey that I have been on. So given that I know my outcome is actually pushing every model that I build to production to make sure that it's actually serving its purpose, I really needed to understand over time what it was that I needed to learn and also where it was that I could actually learn from others. So certainly at the outset for me of my career, my view of building a model was actually the following. I would get access to data and explore it, so solving sort of that first data aggregation checkbox. I would engineer some features, meaning how do I transform data into something that could be pushed into a machine learning algorithm. I would build various models and try and interpret which ones are performing correctly and maybe use that to assess new models that I would want to build. Examine my results, meaning how is this performing over time. And then I was so excited to make my model go live. But inevitably, I found myself at the top of this cliff, not realizing that there was actually a lot more to be done. And so really the challenge that I was running into early in my career was the fact that many folks believe that getting access to data and bringing a data scientist in is all that's needed. And what actually hadn't happened was sort of this realization that data scientists are not, in fact, unicorns in the sense that we were treated as individuals that, of course, were meant to understand data and magically know what to do. And that meant that we also knew how to bring that into production. So really what had happened was that we hadn't realized there was actually a lot more to it. So when you're actually shipping your app, it's not just about getting access to data, nor is it just about getting your data scientists in. There's actually a lot more to it. You need to make sure that you have an application to reach those customers. There have to be pipelines that deliver the models and the scoring services so that that data can actually go into and out of the application. You absolutely need to monitor the health of those models. It is not sufficient to push it into production. You need to know how it's performing. Beyond that, you need to be able to experiment. And with that, you would like to have an agile process to know how to iterate and improve. And then, of course, that means you need ways to deploy new models. Now, all of this might seem extremely obvious to everyone, but it may also be news. And what that meant was that while we really believed at the outset that all we needed was access to data and data scientists, it turns out that over time, everyone has been realizing that there's actually a lot more needed. There are data scientists, there are researchers, software developers, user experience designers, a whole bunch of people. And what I realized was that early on, we likely should have all sat down and rather than treating data scientists as mythical unicorns that did not need to be understood, instead actually try and find things that we share in common so that with those shared commonalities, we might be able to figure out opportunities for reuse and opportunities for learning. So really that allowed me to, over time, realize that maybe data scientists and software developers aren't that different after all. Both data scientists and software developers want to monitor what is happening to their apps or to their models in production. This might not have been something that we thought about on day one, but certainly if we had spoken to a software developer, it would have been very, very clear. Beyond that, we need ways to identify opportunities to improve our models. Again, that might seem unique, but software developers actually also want to find ways to improve and add features. Data scientists often focus on wanting to use new data or new algorithms, while actually software developers are also constantly looking for new technologies and new ways to solve their problems, to scale things up, to make things faster, and to possibly just completely change their approach. Data scientists need new ways to test models. We need ways to experiment. Similarly, software developers need to test new features. And so here again, there are probably similarities that could have been explored much earlier in my career. Data scientists absolutely need ways to redeploy models. It is never a ship, one and done. And the same is true for software developers. They need a way to redeploy their apps. And across the board, everyone needs to consider opportunities for reuse. So for me, it was certainly a learning journey over my years. And what's exciting is that at Salesforce, I've really been able to think about how it is that we need to build a platform in order to give everyone the tools that they need. Software developers absolutely have a suite of products out there. And similarly, data scientists need to be enabled as well. And so while I can certainly say that data scientists have a lot to learn from developers, they also have a lot to share and a lot to give in order to make sure that the models that are supported in production are actually there with a platform to support their needs. This is not really such a new concept. There is an older paper from NeurIPS actually published that talks about how historically we thought of machine learning as being kind of the solution to bringing data science into the world. But actually there was a lot more to it, and that bringing a model into production is quite complex. And so while that little black box in the middle, which is the machine learning code, certainly is very critical and might be hard to understand, we need to think about all of the other things that have to exist around it. So really what I want to turn to now is the concept of how it is that as data scientists, we can work together with others in order to make sure that we're fully supported and have the platforms in place that enable us. So at Salesforce, again, because of the scale that we're trying to reach, we have pushed for many different opportunities to build out a platform that really serves us and our customers. And so while I'm not going to get a chance to go through all of the details, there are a couple things that I do want to highlight. And really, it is around how our platform exists in order to make sure that our data scientists focus their efforts on engineering that next great feature in a model as opposed to building out a particular new element of a platform that could have been actually put in place. Now again, at Salesforce, the scale that we have reached is quite different from what it is that you might be targeting in your roles. Nevertheless, every company, I would hope, is considering how to build out multiple applications. And so while there might be a tendency to go rogue and build many different platforms, I think there's a lot of focus that could be put into how to leverage reuse on the various portions of the platform in order to serve your many use cases. So to start off, I'd like to turn to that box inside the machine learning bit. So while there are other talks that you can check out talking about data services and compute services and orchestration services that allow us to bring models into production, I'd like to start off by really addressing that machine learning side of the house. Just a quick script here when we think about models and maybe what we do, how we evaluate, and how we reuse. So here's just a little script looking at how you might think about using Python in order to load up some data and build a model. So what we've done here is we've imported the SVM support vector machine library, and what we're loading up is some data. So we have some features that have been sort of pre-processed and are ready to go. What we're going to do is separate off some test set for evaluation. We're going to build a model, and we're going to go ahead and evaluate how well we've done on a holdout set. Now, there are a lot of questions that immediately come into play here. Should we try other model forms? There are many different algorithms available at our disposal. Why stop here? Different features. We started off with a certain subset. We might even want to engineer new ones. Even within the support vector machine, should we be trying out a different kernel, different hyperparameters? And then, of course, how do we make sure that we have arrived at the best decision for every model in production? So while this might be something that is engineered for a particular problem and a particular data set, there's no reason to think that we need to do this over and over again. Many people have written many such scripts repeatedly over time, not to mention all of the ETL that might have gone into it. And the issue with that, certainly, as data scientists, is we spend a lot of time focusing on maybe re-engineering or reworking this pipeline on data sets. And I think one of the issues that is clear here is that we have a tendency to believe that this is the first time that anything has been done. And over time, we might learn ourselves that not every data set or every process is actually such a snowflake. There were probably opportunities to find reuse and probably opportunities to learn not only from our own past mistakes, but the mistakes of others. And so really, we also as data scientists need to push in the direction of finding opportunities to reuse and build a platform that supports our ETL and our modeling purposes as well. So for us at Salesforce, what we have is the open source library Transmogrify. What it allows is really the automation of the feature engineering stage and the model selection, so that really the different folks that are working on this can collaborate and identify those opportunities for reuse, and instead focus on how to kind of get that next mile out of the data set. So looking into kind of this approach here around all the different steps, what it allows us to do is compress all of that into an automated pipeline. Now, that doesn't mean everything is perfect, and so if we look here just at the data sampling and feature selection portion, there are actually these repeatable elements in our pipeline that all of us may have looked at in the past. So here's just a sampling of kind of the things that you might be doing on your day-to-day. You might have categorical variables, you might have text fields, you might have numbers that are being brought in. So while I won't go through every example, you can imagine that for categoricals, here we're giving the example of different individuals that might have titles. And we might want to make use of the title of the individual, the business title, whether or not they might be a likely candidate for purchase, for example. And so there you would often pivot those values or use them in ways to group them. On the numerical side, you might be doing transformations, you might be bucketing those, and these can be automated. But let's just turn to the text example. If you look at text data, you can imagine all of the things that everyone has been talking about, but just a simple set of example might be that many of us have written word counts, where you just simply look at the data and transform that into maybe the length of the actual text, which might be informative of what it is that you're trying to predict. Maybe you realize that the stop words are not so important and you would like to remove them, so you need to come up with a way of identifying stop words. Why write that multiple times? Maybe you want to classify it as English. Maybe that means you would like to treat it differently. Again, this is not something that we need to write many times over. It is probably something that we want to reuse. Of course, sentiment. Is that a happy or a sad sentence? Is it neutral? These are actually learning opportunities and sharing opportunities. Of course, it's extremely exciting to get to build that first model, but it's also important to make sure that as we're doing that, we're sharing it. And so really what we focus on is, even in the feature engineering stage, how do we find these opportunities for reuse? That actually means that as data scientists and machine learning engineers, you get to focus on those new problems instead of rewriting that same code over and over again in that new script. Now, beyond just the feature selection, there's also the model selection. So here, what we have done is actually built tournaments of models. While this might mean different data sets for you, for us, our customers actually have different data sets, and we build custom models for every single one of them. So as we bring in a new customer, they will go ahead and have automated feature engineering performed on their data sets, meaning that everything that is derived from their data is in an automated way, in a completely unique way. That also means that they likely are building different types of models. So I mentioned earlier, for example, a classification problem that's balanced as opposed to a rare event. And so you can imagine that different types of hyperparameters and hyperparameter settings and algorithms might actually perform better. And so what we do is actually run a tournament of models and see which ones perform better. And so one customer might receive a completely different algorithm that is performant on their data set with different hyperparameter settings than a second customer. And in this way, we can absolutely automate that entire process and make sure that we're doing what's right for that particular data set. Now, all of this is extremely exciting, and it allows us to iterate and move quickly. However, the job is never done. And the same is true for anyone that is pushing models to production. You absolutely need to make sure that you are collecting metrics along the way to see how your models are performing, not just up front in evaluating whether or not you want to deploy, but of course along the way. So what I'll spend the rest of the time talking about is really how important it is to monitor your AI and why it then allows you to get to the place of agility. So turning quickly over to the critical components of that AI app and what it means for us to iterate, let's go into how we can use metrics to drive that agility at scale. So what happens after you actually deploy your app? I know we had this really nice circle where we talked about how it is that we get to actual deployment, but there are arrows that are sort of going around in a circle thereafter. And so it's really important to understand, again, that it is not a one-and-done situation. And so for me, going back, a decade, really thinking about what it meant when I was introduced to these concepts in software engineering around agility, I was also introduced to the concept of a minimum viable product. So this concept is actually pretty fun, and it actually makes a ton of sense. So if your goal is to build a product and to ship it to your end customer, there are sort of these fun visualizations for what it is that you might want to do. So at the top there, we see this Fast Monkeys blog shows that you might be targeting building a car. And so one thought might be to go through different iterations of building a wheel, an axle, a chassis, and then putting it all together in that fourth stage. And you'll notice that at every stage, the customer is actually unhappy because they don't have a product. In an MVP approach, what you'll actually do is recognize that what your customer wants is transportation. And along the way, you can ship, for example, a skateboard, followed by a scooter, then a bike and a motorcycle, eventually to a car. And it allows you to have customer feedback at every stage. So let's actually think about what that means in an agile process. So let's consider that maybe we're following this minimum viable product approach, and we are shipping at every stage and using an agile process in order to understand what it is that we should do next. So let's imagine we're at the stage of having number 3, a bicycle. And what happens is we build a backlog. So as a team, we have a product manager that is going through collecting feedback from our riders or our customers. And so we have a list of features that they want. For example, they want a comfortable seat so they can ride longer. They would like a self-powered vehicle so they can go further. Maybe they want some protections. They don't have to eat bugs along the way. Shelters so that they don't get wet in the rain. And of course, they want to go faster so they can shorten the travel time. And it's been prioritized. This is sort of what the customers want to work on. Now, the folks that are working on the team, the engineers, what they do is they organize their work into sprints. And we work on 2-week timeframes on my particular team. And so what we can do is commit to saying, okay, we believe that we can engineer those first 2 user stories and deliver those features by the end of the sprint. Now, what's great is we also know that in parallel, our writers are actually taking a look at what we've built. And so they might say, like, hey, turns out I actually want to travel with 3 more people. We're getting that feedback. And we can prioritize that. So while we're working on that next iteration, we're also still continuing to collect feedback and making sure that we're doing the right thing. So that in the next sprint, we can make sure we're picking off the right items. And it turns out that we'll actually, build a larger, roomier vehicle that maybe doesn't go super fast because it turns out that's what's most important. So this is really fun, and this allows us to actually, build something that makes sense. But I honestly had no idea what that had to do with me as a data scientist, because I sort of didn't understand what that meant. I had a model that I wanted to build, and in every turn there were so many ways that I could improve my model. And of course I really felt like everything that I delivered had to be flawless and accurate and do a great job. And what actually happens is that if we're constantly overwhelmed by where we can go and do the actual most performant, accurate possible model, we will never ship. And in reality, what we need to do is the same thing that software engineering practices have been focusing on the entire time, which is shipping the minimum viable, in our case, model, and make sure that we have the tools in place to monitor and to follow up. So what that means is if we have a model in production and we can look at some sort of a monitoring dashboard, you can actually see what's happening. It's absolutely critical, both at the time of shipping your first model, but also over time, for you to be looking at the performance of those models. So how many scores you're writing back, how many per hour per day, and also consistently evaluating how you're performing. Is my model dipping in performance? Is it increasing? And at any point, building alerts around those. So when we see this sort of a dip, if we're imagining here, we're looking at that evaluation over time, we can also trace it back and quickly decide what it is that we need to do in order to avoid this type of a dip going forward. Now again, at Salesforce, for us, that's extremely important because while you might be able to look at one model at a time, remember our scale. And so when we have all of these models in production, deciding the 2 that are actually in most need of our attention requires us to have excellent monitoring and alerting. And I will assume that most companies will get to a point where they have many models in production and are hopefully building for reuse. And so really what you need is to make sure that you deploy those monitors and go ahead and repeat that process. Now, if you have multiple models in production, what you can do is decide to iterate on the ones that are most in need. So if you have a monitor that, for example, lets you know how many are performing above chance, that's your opportunity to focus. So rather than saying that you're going to arbitrarily run an experiment, let's run the experiment that will most help us. So in that sense, what you can do is actually investigate, identify an opportunity for improvement, go ahead and deep dive into that data, figure out what the root cause is, implement the improvement on it, then go ahead and run and review the experiment, see how it performs. Now, hopefully what you're doing is actually running multiple experiments and building into that reusable platform. And so that means that your new feature engineering technique might actually work for another model. And so you should test to see whether or not there are any regressions. Again, this is borrowing from the software engineering principle to make sure that there are no changes in performance. And then we can go live with that model. And from here, we can just continue to iterate and make sure that we focus on that right area. Now, generally that means that you're going to create your own backlog of tickets for data science. So for example, it might be an investigation that you've noticed a drop in some sort of an evaluation criteria that you have, and that you'd like to accept. Your acceptance criteria of whether or not you're done with that particular investigation is that you've identified the root cause, and you're going to create the follow-up stories that you believe are the right tickets to go. For example, it might be identifying new hyperparameter settings for a random forest, because it turns out that you need either more trees or deeper trees. From that, you would provide your output of the experiment and assess whether or not to go live. Turns out you might also have new things that you're trying to explore that live on your backlog. For example, maybe you're using leads to predict whether or not there's conversion, and so maybe you want to add some new object into the model and combine more data. And so there you could have a different story that can live on your backlog to assess whether or not you would want to add that. There might be those really new kind of cutting-edge techniques you're trying to go after, which is automating segmentation to multiple subgroups for your models. This might be something that you want to design up front and discuss with your team as a whole, and so that also can live on your backlog. And just like anything else, there could be bugs. So it turns out that maybe the way you're handling blank text isn't great, and you would like to handle it differently from maybe a null. And so that could be something that lives on your backlog as well. So what that means is over time, rather than endlessly thinking about where it is that you could meander, you can really focus on what it is that is, immediately able to add value. Where it is that your models are most in need and what it is that you want to focus on. And that allows you to really understand where to spend your time. So this means that rather than kind of aimlessly exploring and holding yourself back from iteration, you can feel confident actually that your monitors will allow you to actually train a new model that is the one that's in need, increase your overall metrics for how you're performing, and then really focus on how to get more models into production, not just around finding perfection. Now with that, I would like to really go to those key takeaways, things that I hope that you have heard in this session that will resonate, and that whether you're in the middle of your journey or, starting it out, think about where to head next. And if not, hopefully open up a discussion around how it is that you're doing these things today, because I'd really love to hear from the community at large on how others are solving this. So in any case, certainly if you're on the outset of your journey, please plan for multiple apps. While at Salesforce we are achieving a very large scale, it is true that any organization will hopefully have many models in production. And so really think about those opportunities for reusability, how to leverage, for example, the way the data is being stored and accessed, and certainly down to the machine learning pipelines. Don't force yourselves to rewrite that code every single time. For your data scientists, really think about how to support them. Build a platform that enables their productivity. It's not just about telling them to use software engineering principles. It's also about understanding what their needs are and how those can be addressed. Above all else, do not fly blind. Metrics are critical for you to understand how you're performing, and monitors that allow you to alert when there's a problem so that you can focus your energy on it immediately. And beyond that, of course, never deploy without a plan for iteration. Your data scientists absolutely need a way to experiment. They need a way to redeploy, and you need to decide what it is that you want to do with any old predictions that you have shipped. So just some thoughts to head out with there. So hoping everyone is excited about what I've presented today. In particular, we'd like to have you participate in the open source community with Transmogrify. So head to GitHub and take a look at what we've worked on. And of course, if you're interested in looking at any of our actual products, feel free to browse those Einstein services as well. Above all else, thank you so much for your attention, and feel free to reach out to me on Twitter there at @iTweetSarah. Thank you.
Oh, thank you, Sarah. That was a very insightful talk. We covered a lot of bases, from the basics of data science all the way to really the advanced methods of putting models in production, which, I've seen this over and over again, that putting models in production is really the greatest hurdle to data science becoming a little bit more widespread than it is already. I mean, it is one of the hottest topics, but it seems to be one of the key hurdles. Why don't we go over to the questions and the Q&A section here, and start with one of the very basic maybe ones. Ashwin asked, how do I start with learning data science as a complete beginner? I know that's very basic, but let's start maybe at the very beginning.
Absolutely, yeah, that is such a great question. Certainly folks on my team have come from a broad variety of backgrounds. I know at the beginning of this talk I talked about how the industry originally has been asking for master's degrees and PhDs. I came from a biomedical informatics background. I started off in college with biology and then added computer science to it. I have folks on my team that have math backgrounds, neuroscience backgrounds, and a variety down to bachelor's level in math. So I think to get started as a complete beginner, there are tons of resources out there. So there are lots of free courses available to you online on a variety of platforms. We also have some modules that allow you to learn. For me, I think what's critical and what I encourage people to think about is really as a data scientist, there's the engineering side and there is the science side. Not everybody is going to enjoy looking at data. I know that for me personally, when I'm given a data set, I can stay up all night asking questions, exploring the data, building models, understanding where it's broken, and iterating, and finding out what the best next technique is, where my problems are. So I think getting started in data science is learning some fundamentals, but then also getting access to data, and especially messy data. It will rarely be clean, and understanding whether or not that's your passion. I've had people on my team that really think that they would like to transition from engineering roles to data science roles. One person in particular, Natalie Casey, who will be at Grace Hopper, actually has a fantastic viewpoint on what it is to be an AI software developer and understand whether or not your passion is actually data or working close to AI around supporting it, around visualizing it, and seeing what it is that your passion is in the space. So sort of a long-winded answer, but quick fact, check out some online courses, play with some data, and then find out what you like about it.
Yeah, and if I may add, I think if you're here on the ACM Tech Talk series, I'm assuming you're an ACM member, and the ACM Digital Library has lots and lots of books and online resources that you can access for free. So great place to start just browsing a few of the books. Maybe a little bit more specific, there's a question, as an application developer with an interest in data science and a strong background in mathematics, could you recommend resources where we could find information about the strengths and limitations of machine learning models? So much more specific, what are the strengths and weaknesses of certain machine learning models and how do I find that?
Yeah, so there are actually a few, and again, actually you might be better in terms of ACM resources. I find it that there are a few great, talks out there that actually talk practically about use cases. I certainly remember that in my own courses, there was a lot of deep theory, and that's super fascinating, and sort of to Efrain's point here that there's strong background in math might mean that you're excited about the algorithms. And sometimes that does mean that you can see the deep underlying theory, but for example, if you're trying to build, a regression model, whether or not you're trying to project outward into the future, then there are these shortcomings, like in a random forest, you would never be able to predict something that you haven't seen in the past beyond the range, whereas, a linear regression might project further out. And so these are these small little nuances that hearing use cases, studying them, for different types of approaches, large data sets are required, and then sort of the neural network space, the type of data. I think it's important to find the right resources, certainly for online education, but I also very much find conference talks with practical, this is what we worked with and these are the problems that we encounter, tend to be the most accessible ways that really frame it in a problem space that is very accessible, and then they go through the different approaches they used and where they fell short.
Excellent. I have a number of questions related to the platform itself and what's really under the hood, and maybe some of the open source algorithms that you use. One was specific about TensorFlow and how much it is used in platforms today. And other questions are more generic about what kind of open source do you use as part of your platform today?
Yeah, absolutely. So The open source component that I can certainly talk about is Transmogrify. So that is Scala Spark. So what that allows you to do is really use a type-safe approach. It's focused around production machine learning, and it uses the variety of algorithms available in MLlib in the machine learning library for Spark. And really the secret sauce above all, if you check it out, is around how to automate the feature engineering. If you have a string, what are the different types of transformations that can be applied? If you have a numeric, what are the different types of ways to bucket? So really how it is that you can take in structured data that comes in a variety of formats and bring it together. Beyond that, really the machine learning side, and I think this is a little bit of the unfortunate element as well around the representation of the platform, is the tiniest little black box inside the platform that I showed earlier on the slide was really, that particular algorithm, which, going back to the earlier question on data science, the algorithms are fun and fancy. And certainly kind of on the engineering and math side principles, it's very exciting to think about them, but all of the work is really generally around data and how to clean it, how to get access to it. So for us in particular, I encourage you to sort of check out Transmogrify and take a look around that. As far as, the various other approaches, I definitely encourage you again to check out how it is that folks have put these different frameworks into production. Are they using containers? Are they, warming up? They're different approaches, and lots of talks and publications and blog posts on it that are extremely exciting ways to check out, the shortcomings, the benefits, and I would encourage you to ask lots of questions there as well around scale, around uptime.
Great. I think we have probably time for one or two more questions. So they're actually streaming in rather quickly now, so I'm having a hard time to even keep up. One also related to the platform is how do you handle a situation in which the data science prototyping platform is different from the deployment infrastructure? Because a lot of them might be just legacy systems.
That's such a great question, and this really goes back to kind of that platform discussion. At Salesforce, we've really focused on how to make sure that the platform itself allows in-platform secured experimentation, meaning that going from prototyping to production should be quite seamless. And so, of course, at the outset, many of us think about working in scripts and doing quick iterations, but very quickly, if you think about ways to actually use the exact same platform to build prototypes, and there are actually other tools out there that allow you to productionize scripts even. Not that I necessarily encourage that, because again, you want to think about how you actually build in monitors and metrics very quickly. But I think as you're headed down this journey, if it is that you need support from your management, again, it's all about leveraging what has been built before. And so while it does make sense sometimes, there are a lot of fun graphs about kind of the more deliberate, slow approach to getting to stage 0. Data exploration is great, but if you're building reusable tools, it actually turns out that building a model going from 0 to 60 over time becomes much quicker if you are building inside of these reusable frameworks. For example, like with Transmogrify, your early data exploration can actually happen pretty seamlessly by monitoring, what isn't performing and then diving into the data to making those iterations. So I would really, really encourage you to not, work on your laptop on a completely different script without thinking about how to start from the reusable baseline that somebody else has maybe started on coming before you.
Excellent. And maybe one last final question. Again, I think platform seems to be the recurring topic. This about large data volumes. And the question comes from Stephen. It says, in many cases, data are in large volume, and it is difficult to bring the data across different platforms. So is it the best idea to deploy a model on the platform where the data resides, or is there a recommendation in terms of deploying models on the platform where the data resides, or should we probably assume that it can be accessed remotely?
Yeah, no, that's such a good question, because sometimes you might be building a model in sort of one locale and then absolutely deploying it. This is one of those instances where it's extremely important to work with the engineers and the developers, because there might be latency considerations, again, questions around whether or not you're even able to access or deploy things. Above all else, I think it's difficult to offer blanket advice on these types of topics, because it depends type of situation. I think what's extremely critical in all of these instances is to make sure that even if you do deploy and sort of into another platform where it resides, that you still have ways to monitor it and to alert and to make sure that it isn't going rogue or it isn't misbehaving. Because again, going back to kind of AI needs to be trusted, I feel there needs to be a responsibility. It does not mean that you need to be looking at the data. It's simply that you know when you need to go in and help, rather than allowing it to kind of fly blind and go off the rails.
Excellent. I'm afraid now we have run out of time today. So again, I'd like to thank Sarah for her great presentation, a lot of the insightful answers. Thank you again to your questions. And a special thanks, of course, to each one of you here for taking the time to attend and participate today. This talk was recorded and will be available online in a few days at learning.acm.org. You will find announcements on upcoming talks and other activities, ACM activities, at learning.acm.org and on acm.org. Also, of course, don't forget to fill out our quick survey at the end, where you can suggest future topics or speakers, which you should see on your screen. On behalf of ACM, on behalf of Sarah and myself, Michael Sauer, I thank you again for joining us today. I hope you enjoyed this presentation as much as I did, and will join us again in the future. And maybe I'll leave you with one Einstein quote at the very end. Long before there was machine learning, Einstein once said, "Information is not knowledge." So what that means for me is really to leverage your data, you need to leverage your machine learning algorithms in production. You need to put those models in production, and then you can generate knowledge from them. So with that, we're concluding the talk today. Goodbye, and thank you again for attending.